Hi, in today's lab, what I'd like to do is I'd like to talk a little bit about buffer overflows, what they are, and in order to do that, I'm going to be writing a small application that is going to be vulnerable to a buffer overflow. And then what we'll do is we'll actually patch the application with a bare minimum patch, but we'll make it so that way the buffer overflow will not happen. So what I'm going to do is I'm powering on my Ubuntu machine, and I'm just going to open my console here. And what I want to do is I need to install some software. So in order to write applications, we'll need to have certain things like a GCC compiler. We'll need certain tools. So we're going to start by just going to my dash home button here, my Ubuntu home button. I'm just going to click on that, and I'm going to type in term so that way I can get to my terminal. And once my terminal is open, I just want to install using the apt-get. So I'm going to just do sudo. I need to be a super user because I'm going to install software. apt-get, and that's the tool we're going to use to download the software we need from the location. Install. And I want to install build essential. So after typing in build essential, I should be able to hit enter. Password's password. And I'm going to say yes. It's saying there's some prerequisites needed. So these are going to be all of the libraries and different things that we're going to be using when creating this application. So the first thing I'm going to do is I'm just going to create a hello world. I like to start with a very, very simple application so that way it gives me a starting point and I understand how the language works. So there's a lot of different editors we can use. I'm just going to use gedit for now. It's pretty easy to use. So I'm just going to type in gedit. It's kind of like Notepad. And then I'm going to do a space. And I'm just going to call this thing hello.c. So when we're writing within the C programming language, the convention is always to give it an extension of .c, so that way you know that this is source code. So I'm just going to hit enter. And I open up a blank text document that says hello.c. So the first thing I want to do is I want to do an include statement. So it starts with a pound sign and then the word include, a less than, and then it's stdio.h and then a greater than. So what this line is, first of all, it starts with a pound sign, which means that it's a preprocessor directive, which means before it's compiled, it needs to do this action, and the action is going to be including an H file, which is kind of basically a library. Somebody else wrote code that we're going to be leveraging. So for example, in this application, we're just going to put the word hello world out to our terminal window. So we're going to be taking text and we're going to be displaying that text within a terminal. There's actually quite a bit of work involved in doing that. Somebody else has done all of the low-level plumbing to do that kind of work. So what we're going to be doing is we're going to be using that code, and we're going to be using a method they created for us, which is print or printf, either one. So we add this line, and that just gives us a lot more functionality within our program. So now I'm going to use the word main. Now, One thing to note is the word main is lowercased. All right, so this is a case-sensitive language, so if you used a capital M, that would actually be incorrect and the program wouldn't work. So I'm doing an opening and closing parenthesis, which means that it's a function. And I'm going to do a curly brace, opening curly brace, and a closing curly brace. So I've got a couple curly braces here, which is basically saying this is scope. So every program needs to have a starting point. So that way when the program starts up, it knows where to start reading code from. Within the C programming language, you always start within your main function. So that's what we did, was we just created a main function. So as soon as we run the program, it's going to know to look in between these curly braces to find the code that needs to run. So what I'm going to do, I'm just going to do tab just for spacing, so that way hopefully it's a little bit easier to read. I'm just going to type in printf, opening paren, and then double quotes and closing paren and a semicolon. So this is a print statement, and technically it's been extended. Printf allows us to do some formatting that we'll take advantage of a little bit later. So the opening paren means that this is a function, and right now we're passing nothing into it. Inside those double quotes, I'm just going to type in hello world. So I'm just going to save this. If I hit my little floppy disk, my save. So I've got printf, hello world, and then I've got a closing parenthesis, so those are parens, and then I've got a semicolon at the end. So within the C language, every line of executable code needs to end in a semicolon. So this is what's called source code. Source code is just text. It's human readable text that we're typing in. So thank God we don't have to be at a low level where we're typing ones and zeros, or even assembler where we're doing pushes and pops and different stuff down at that level. We're at a higher level, and there's even higher levels from C. C is actually an older language, and there's more modern languages that give us more functionality. But for right now, we're going to use C, and I think C is a great language to use, especially when talking about buffer overflows. Okay, so I've got my source code all written here. So I've got an include, and I'm including in the standard input-output library, the stdio.h. H means that it's a header. There's an implementation file that comes along with that, but all we need to do is include the H file, and it allows us to do things like print. If this line didn't work, we could not use print. So we're printing hello world out to our prompt. So what I'm going to do is I'm just going to hit the save, and then I'm just going to close this down. So at this point, what we just did is we created a source file. After creating that source file, what I want to do is I want to compile it. All right. Now what compiling is it's the process of taking source code, human readable source code, and then the compiler takes each line, it reads it, and it interprets it, and then it creates a binary file of the same thing. So instead of us writing all that low-level binary stuff, we use the compiler just to bridge, and it says I'm going to take everything that's human readable, and I'm going to create a file that is no longer human readable, it's binary, and it prevents us, or it allows us not to have to write at that low level. So GCC is the compiler that we would use on Linux. We can use GCC on Windows, but there's other compilers on Windows as well, like the Visual C and even C#, and there's other languages that are more popular on Windows. But on Linux, GCC is something that you'll probably run into if you're going to program. So this is how you compile a program. You type in GCC into the terminal, and then what you need to do is you need to identify the source file. In this case, it's hello. And if I hit tab, it should automatically finish typing it for me. Hello.c is our source file. Then I'm going to do a space, and I'm going to do a -0. Not a 0, it's an O. O stands for output. All right, so I'm using an O, and that's called a flag. So the minus sign and the O is going to tell GCC that we are going to put it out into this file, and I'm just going to call it hello.exe. Now on Linux, technically we don't have to use the .exe, it's kind of a Windows thing, but I'm just doing it so that way it'll help us realize that this is an executable binary program. And the C, the .c, is source code. So I'm going to hit enter. So right now it just went through and it did all the work. It read in our text file and then it converted it into binary. And now we have a hello.c, or I'm sorry, a hello.exe application. So if I want to execute that hello.exe, I'm just going to do a dot forward slash, which means within this current directory. And if I start typing in hello and I hit the tab, I see my hello.exe. If I hit enter, oh, there it is, right there, hello world. Hello world did print to our terminal. All right, so we do have hello world here. So what we're going to do is we're going to want to add in some carriage returns around it. So that way it's a little bit more easier to find. So in order to do that, I need to go back to my source file. If I hit my up arrow key, it'll get me back to the gedit space hello.c. If I hit enter, this is going to open up my source code. So I've got my printf, opening paren, double quote. If I click within that double quote, so in between the double quote and the H, what I want to do is I want to add a couple escape characters. An escape sequence is a backslash. So I'm going to do a \n, which stands for new line. So I'm going to do new line, which is going to do a carriage return. And then after the hello world, I'm going to do a /n/n. So basically what we did here is we said hit the carriage return or hit the enter key. So we got a blank line in front of hello world, and then after we print hello world, we'll have two more blank lines, and then we'll see the prompt. So we just modified our source code. So we had source code, we compiled it into binary, we ran the binary, we didn't like the output, so now we're going back to the source code, we're modifying the source code. So if I save it, at this point if I were to rerun the hello.exe, it would still give me the hello world over here because we need to recompile it. That is the old binary. So to recompile it, I'm going to use the GCC again. So I'm going to hit that up arrow, and eventually I'll see the GCC hello.c space -o hello.exe. So if I hit enter, that was pretty quick. What it did is it took those modifications and added it to the new hello.exe. So now if I rerun hello.exe and hit enter, I now see my hello world is right here. So I can see that the changes that I made took effect. So hey, we just wrote our first program, which is kind of cool. We actually wrote some C code in Linux. We compiled the C code into binary, and now we executed the binary, and we saw our program run within our terminal. So that's our very first application that we wrote using the C language. So what I'm going to do is I'm just going to grab a screenshot of this, so that way I can submit this. So I'm just going to open up WordPad, and I'm just going to grab a screenshot. So I'm just going to move this a little bit, and I'm going to do my function screenshot, print screen. I'm just going to paste this in here. I'll minimize that. Okay, so I've got my first screenshot done. So we just created a hello world. All right, so that's kind of cool. So what we're going to do is we're going to expand on that a little bit. I want to write another program that's a little bit more complex. And this is going to be the program that we're going to use to show how a buffer overflow actually works. So what we're going to do is we're going to create a brand new file. So I'm going to go back over to my gedit. I could hit the up arrow if I wanted to until I saw gedit hello.c. instead of naming it hello.c, I'm just going to give it my last name, and you're going to give it your last name. So everyone's going to have their own source file. So I've got gedit. My last name is Wetzel, so it's wetzel.c. I'm going to hit enter. And now I've got my blank document. So in this program, I want it to ask, like, what is your name? So it's going to allow us to type in our name, and then it's going to spit back out that name saying, hello, Joe, or hello, Bob, whatever the name is. So basically our program is going to solicit input. It's going to ask us a question. The end user is going to have to respond by typing something into the keyboard. When they hit enter, we're going to take what they typed in, save it into a variable, and then we're going to run another line of code which is going to take that variable and then print it back to the screen. So we're going to need to be dealing with that screen again, our input-output. So we're going to be reading in from the keyboard, and we're going to be printing out to the screen with the print. So I need to use that include statement again, the stdio. So I'm going to do an include less than stdio.h, and then a greater than. And that's my standard input-output library. I need to do main, because that's where everything starts from, and it's a function, so that way I need the curly braces around, and I need the parentheses. So I've got my main function here. So everything in here is going to execute when we type in this case, the wetzel.exe. So after it gets compiled, this is the starting point. Okay, so I'm just going to tab it so that way it's human readable. So what I want to do is I want to create a variable, and this is really the root of where the buffer overflow is becoming vulnerable. So I need a variable, and in this case I'm going to hold a name. So a name like Bob is a character array. Basically it's a variable that has multiple pieces of data held inside of it. So if I think about like the word Joe, J-O-E, it's got 3 different characters. It's got the J, the O, and the E. So I'm going to have one variable that holds 3 characters. So the way I would create a variable like that is going to be an array of characters. So a character is a char, C-H-A-R, and then I got to give it a name. It can be anything I want. I'm just going to call it username. And I need to determine how big this username is. So when we're dealing with an array, we need to use the square braces. So I'm going to use a square brace, and I'm going to just give it 10 and another square brace and then a semicolon. So in this case, we've got 10 characters that can be used. So J-O-E is 3, and then I've got 7 more that are just going to be left blank. If I did hello world, H-E-L-L-O-W-O-R-L-D, without a space, one word hello world is 10 characters. If I used a space, that wouldn't fit in our variable. Okay, so that's really what we're dealing with here, is we're creating a variable and we're going to put stuff in the variable. So what I want to do is I want to start out by printing off like we did before. I'm going to hit my tab and I'm going to type in print F. And I want to print a question to the user, our end user, and I'm just going to ask them what their name is. What is your name? Question mark. So at this point, we put a place aside in memory that can hold stuff, and we're prompting to them to give us their name. What is your name? So at this point, they're going to have to type in like Joe or Bob or Steve or Mark and then hit enter. In order to do that, we're going to use something called scanf. So scan will scan the keyboard buffer and allow us to pull the data from the keyboard buffer and use it within our program. Print prints out, scan pulls in. So that's going to be our input. So I'm just going to type in scanf. Okay, and in order to use the scan, we need to use replacement characters. So it's going to be a %s. Um, and then this is going to be username. So I'm just going to give you a second to type this in, and then I'll kind of explain this. So it's scanf, open paren. Then I've got double quotes with a string here, and it's a %s. Then I've got a comma, and then I've got username, which is my variable name, and then I closed it up. So the way that the scan works is the scan uses input. So the user, let's say they type in Bob. That's a string. So the %s represents any string that the user typed into the keyboard. What it's going to do is it's going to take whatever they typed into the keyboard and it's going to place it inside our variable that we allocated earlier. All right, so you always got to say, I set some space aside to hold whatever is being entered. Here's what's being entered, and that's just a replacement character. It'll actually, if I typed Bob in, it wouldn't stick the %s in there. It'd stick the Bob in there, or the Steve in there, or the Mark. So, and there's other percents. So, for example, there's a %I for integer, or %f for float. So there's different data types that can be pulled in from the scanf. For right now, we're just going to focus on the %s. Okay, so now we've got a variable that it's going to hang here until the user hits enter. Once they typed in Bob and hits enter, it then will grab that word Bob and it'll put it inside the variable, and then it'll go on to this next line of code. So the next line of code, I'm just going to do a print again. I'm going to do printf, and this time I'm actually going to use the format. So I think I'm just going to say something like hi. Oops. I'm just going to use the %s again. Hi Bob, comma, how are you? And since there's a comma there, I probably should use the lowercase how are you with a question mark. Hi Bob, how are you? Okay, so that looks good. So the printf has the ability to use these replacement characters as well. So I'm using the %s, and then I can use a comma, and then the first %s is going to be the first thing after the comma, which will be username. And I could do another % somewhere in here, and then I could have another comma and another variable. So you can daisy chain as many variables as you want inside a string with as many replacements. So right now, this one is aligned with this one. If I had a second one, I'd need another comma and another variable. So at this point, I do believe that I've got some code here that will function. If you missed any one of your semicolons, you'll get an error message. Actually, I'm going to forget one for now, just to show you what that error message will look like. Or if I capitalized maybe the S, that would be another big no-no. So if I save this and I close it, and I'm going to just do that GCC compile, GCC, and it's my last name, W-E-T. I'm going to hit tab, and then I'll finish typing it. -O for output, and I'm just going to use my last name again, WETZEL.exe. So I'm creating an executable of my last name. So if I run the GCC compiler, I'm getting some problems here. So it's saying it's expecting something before that. So it basically threw an error message. So if you get any error messages, what you're going to need to do is hit your up arrow until you get to the gedit and the last name. And you're really going to have to scrutinize your code. You're going to have to take it one line at a time and slowly look at it, make sure you don't have caps. I do everything lowercase just to make sure that I'm not messing anything up here. And I'm going to make sure that every one of the lines within that main body here, they call this the body of the program, every one of those lines ends within with a semicolon. the scanf has got a comma, and the printf. So it should end up saying, hi Bob, or hi Steve, how are you? Okay, so if I save this, I fixed my errors. So you're going to have to always go back, fix the errors, and then try to compile it again. If you run it and you don't get any negative feedback, that's good. That means that it functioned correctly. So in order to run the program, I need to execute it from within the directory, so I'm going to have to do that /WE, and if I hit my tab key, it'll finish out my last name.exe, and I'm going to run it. So I kind of wish I would have put some new lines in there. So what is your name? I'm going to write Joe. Hi Joe, how are you? All right, so I can see that it worked. I'm going to make it look a little prettier because I think I could have did better with formatting. So I'm going to hit my up arrow until I get to my gedit. So I've got gedit and then my last name. So I think I'm just going to do the \n for new line. So it's going to do a new line saying, what is your name? And I don't know how I felt about it letting me type after the question. That actually didn't seem too bad. But I think I'm just going to do a new line and let them type underneath. And then afterwards, the hello, I'm going to throw a new line on that. Actually, I'm going to put 2 new lines just to make sure that goes down a little bit. And then I'm going to do a couple new lines after how are you. So maybe I'm adding too much space. I'm going to run it again and take a look at it. But I think this at least should be a little bit more obvious on what we're doing. So I'm just going to save it. Because I made changes to the original source code, I'm going to have to recompile it. I always have to recompile it using GCC if I change the source code. So now I changed the binary. So now I'm just going to hit that up arrow until I get to the .wetzel.exe. I'm going to run that. What is your name? I'm going to type in Bob and hit enter. It says, hi Bob, how are you? Awesome. So we're using our variable. So at any point in time I could say anything I want. Steve. Hi Steve. So it's soliciting input. It's using that input and rebuilding a string and displaying it back out. So it's a little bit more complex of a program. So what I want to do is I really want to talk about the buffer overflow. I'm going to open up my source code. And what a buffer overflow really is dealing with is where we've got a variable. We declared a variable. We set some memory aside in the computer, said, hey, I'm going to use 10 digits, all right? And then we're allowing the user to type in anything they want, all right? So they can type in their name, they can type in anything they want. And we're then using that variable. This is a real program, a real style of program. And the problem is if the user types in more than 10 digits, at that point, we're smashing the stack, which means that we're overflowing the allocated space. And now it's starting to write in areas that maybe we didn't allocate for. So I've actually got a separate video that kind of goes really low-level techie geeky on what a buffer overflow is, what a stack looks like, and how that stack actually can be manipulated. And how it can be manipulated is if the user actually types in malicious code into the scan, writes the malicious code into the username, and then the return is actually going to be pointing to that variable. So it is actually technically possible for somebody to write evil code and then running the program take advantage of it. Okay, something that's new in this version of GCC is it's actually not throwing an exception right away for us. So what really should be happening, if I take a look at my source code, as soon as I'm over that 10 characters in the array, if I type in a username that's larger than 10, it will throw an exception. what's happening is within this version of the GCC compiler, it's allowing me to, okay, so I'm just going to recompile this. And if I run it, what is your name? If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then this is bad. Really what should be happening is it should throw an exception. The version of the GCC compiler is writing all of that into the buffer, and it's reading it back out of the buffer. So it's allowing me to actually do an overflow, which is out of bounds. It's considered to be unstable and unreliable, but it's actually allowing me to do something that that isn't isn't the best. But what they're thinking is that you've already crashed the program. They're just doing their best to help us keep it alive. So previous versions, that actually would have been the beginning of a buffer overflow because I allocated 10 digits. What they're doing is they're giving me a pocket of space, which I'm not exactly sure how big that pocket is. But if I'm just frantically typing into the keyboard and then I hit enter, now I got my buffer overflow. So I overfilled whatever they allocated. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's double the space that I allocated. I allocated 10, I just put in 20, and it actually ran fine with 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it did not go well for 30. So somewhere, between 3 times the amount. So it even went over double the amount. So once I put 3 times the amount in there, then I saw that I've got the stack smashing and the buffer overflow. So at this point, the code is vulnerable. It's a little bit different than it was in previous semesters with older versions. So as compilers change, they're still trying to figure out how to detect stack smashing and buffer overflows, and they're doing everything they can to try to prevent it. But you can see if we type in a lot of data, we fill the buffer up, and then we did get that buffer overflow. So I'm just going to grab a screenshot showing that I did actually get some smash detection. So I'm just going to go back over to my WordPad here, and I'm just going to grab that screenshot. I'm going to put that in here. And now what I want to do is I want to actually correct the problem. I don't like relying on things like compilers to fix problems. I don't like frameworks dealing with it. I really think the best thing to do is to handle at a code level. So buffer overflows can be completely eliminated if programmers check the incoming data to make sure it matches the bounds that they're setting up. For example, this scanf, we're just taking in a string and putting it into our variable. The variable we allocated 10 spaces, 10 bytes for. What I could do is I could do the %10s, and what this will do is it'll accept the first 10 digits within the string and then place those 10 digits into the username. This would completely eliminate a buffer overflow. So if I save it and I close this down, and I need to recompile it again. So now I've got my better code in here. And if I run the program again, and this time I'm just going to hammer on the keyboard, which would definitely give me some stack smashing. And I'm going to hit enter. It didn't do any type of overflow. I'm not overwriting any sectors in memory. So at this point in time, it took the first 10 digits and it just stopped, printed those first 10 digits out, and the rest of the program ran correctly. So I'm going to grab a screenshot of this as well. And I'm just going to put that into my Word document. Okay, so that is what a buffer overflow is, and that's one way of preventing it. It really wouldn't be the way that I would recommend doing it. I mean, in the real world, I would probably make some more user-friendly type of interface saying, sorry, usernames are only allowed to be 10 digits in character. I would do my best to guess what a good size for a username is. I'd probably guess it probably about 25 characters. I'd decide on somebody with a really, really long name. But yeah, anything over 25, I'd say, sorry, that doesn't adhere to what I consider to be a valid name. So all I really did to fix it, bare minimum, was within the scan F, I just put a %10s, and that 10 is just matching the 10 for what my character size was. So for this project, at the bottom of the document, I ask you to write a small paragraph describing the dangers of what a buffer overflow is. Well, you know, to be honest with you, a buffer overflow is the #1 cause of remote code execution vulnerabilities. So like people have services and programs that are running on ports that allow data to come in. If they're not validly checking what's coming in, it can do a buffer overflow, and it can actually allow remote code execution. So things like Metasploit, we're actually using buffer overflows, and we're triggering a buffer overflow on a remote machine that's allowing us to do things like the reverse interpreter shells, which allow us to type in commands. So that's really what a buffer overflow is. So how are ways that you can prevent someone from doing a buffer overflow to your application? You can really check your input. So when I'm saying check your input, I really want you to think a little bit deep on inputs. So for example, the Wii, the Wii gaming console, there was something called the Twilight Princess hack. So there was a version of Zelda that allowed people to basically install code to the Wii console, the homebrew channel, and they did that by using an exploit within a saved game file. So within one of the Zelda games, when you go to load a saved game file, it's actually on a little SD card that's plugged into the Wii, and all of the saved games are there. Well, somebody figured out that they could grab that saved game and modify it in such a way that they could do a buffer overflow on Twilight Princess, which allowed them to actually execute code within the Wii's operating system. And once they were able to execute code, they were able to install a whole homebrew channel, which allowed them to load more code and do it easier. So there's a lot of different areas that you may not even think that the user would touch, but you got to remember, anything that the user can touch, they could modify, and it could be a potential vulnerability. So if I was pen testing an application, I would probably try corrupting like the config file or an INI file, any type of saved file or an open file. So you got to really think more than just where the user can type in. Sometimes it could be a remote port that's listening for incoming data. What happens if I give it incorrect data too big? What's going to happen? So those are all the different areas that I kind of want you to think a little bit about when you're coming up with ways of testing or preventing somebody from doing a buffer overflow in your application. So anyways, this is a quick overview of what a buffer overflow is. Hopefully you found this video informative.